We're now going to turn to sp2 plus p hybridization, which is the scheme responsible for SN3 and SN5. We will again be doing quantum mechanical mixing. Psi1 equals some constant, phi1 plus phi2, psi2 equals a constant, phi1 minus phi2. And put in chat, in these formulas here, are we mixing phi1 equally with phi2? And the answer is yes, they're equal. They're just pure additions of the two or subtractions of the two, and that's equals to C equals 1. Is all quantum mechanical mixing equal? Have we considered cases, for example, orbitals at different energy, where this one goes down a little, this one goes up a little, the down one looks like the down one? Have we considered cases where the mixing is not equal? And the answer is yes. And those cases are where C is not equal to 1. And so we're going to consider here mixing where C is not equal to 1. One orbital will look more like one of the original orbitals, the other one like the other. In any case, our starting point will be the same. We're going to start with, here's our carbon atom. We put crosshairs to locate it, and it has 3 p orbitals at higher energy. Remember, our goal is to make sp2 plus p. And at lower energy, we have the s orbital. And we're going to start off first by making this one our phi1, and this one is our phi2. But we're not going to mix these two orbitals equally. We're going to mix it so that it's phi1 plus just a little of phi2. So this will be a predominantly, and we add them together. First, let me just draw the picture. And we add the two to make a psi1. It's located, here's psi1, located on this side. And if I make the two predominantly on phi1, will the energy be closer to P or S? Put it in chat. This is predominantly on P. It should be closer, put it in chat, to P, which is why I put it higher. And if the one mixing is predominantly on P, the second one will be predominantly on, put in chat, it will be predominantly on S. So when I make psi2, it'll be predominantly on S. I make this side bigger. This is psi2. And notice they are not at equal energies. And I carry over the two orbitals that I haven't mixed. This one here, and this one here. So this now are our new mixed set of 4 orbitals. An orbital predominantly on S, an orbital predominantly on P, and 2 p orbitals. We need a new phi1 and phi2. And our new phi1 is going to be this guy. And our new phi2 will be this one here. So that's going to be phi2. That's going to be phi1. And this one, thank goodness, we're going to mix them equally. But let's see what that looks like. First, let me draw phi1. So let me just change the colors so we can see that. I'll make that color, and so I can contrast it, I'll use this color here. This will be phi2. So I'm going to draw phi 2 right now here. This is phi 2. And I'll draw phi 1 here. And this whole thing together is going to be psi 1. So, in what region of space, and let's do it by clock, where are these two, where are the two lobes most in phase? 2 o'clock, 10 o'clock, 8 o'clock, 4 o'clock. Put in chat where they're the most in phase. And put it in chat. They're most in phase at around 10 o'clock. They're both positive there, so the lobe will be big in that direction. And then where else are they pretty well in phase? Here, I'm going to make this blue easier to see. Where else are they pretty well in phase? And the answer is they're not bad at around 4 o'clock because they are both in phase except for one of them is just a nub. So when I do that, I won't make it quite as big because the nub isn't as big. I'll make it like this. That is psi 1. And now let's make psi 2. Psi 2 will be the same. Phi 1, the same phi 1. There's my phi 1. Now I'm going to draw minus phi 2. So I switch the phasing. And now, put in chat, at what o'clock are these two orbitals most in phase? At what o'clock? Where do they overlap and are in phase? And the answer is 4 or 5 o'clock. That would be big. And at I already did the other one. And then just like in the previous picture, at around 1, 2 o'clock, they're also in phase, but not quite as much because one of them is a nub. So that's psi 2. And I'm going to draw psi 1 and psi 2 here. So let's go back to this picture here. I'll put them in black so we can see it. We're mixing them equally, so here they are. Here is our psi 1. Here is our psi 2. What is it they mixed to make those two? And what is it now that we need to do? Carry over the remaining orbitals, which were this one. And there was one p orbital that never got used here. This is sp2 plus p hybridization. And it's very common to not use axes, but instead put the carbon atom in the center of a triangle. So I'll do that right here. We're not changing the orbitals, we're just changing where we put the lines. And we find, we find that in each of the directions of a triangle, sp2 plus p hybridization points a lobe. That's a trigonal plane they're pointing in. That's perfect for SN3. What other geometry has a trigonal plane in an equilateral triangle of atoms? What steric number? Put it in chat. SN5.